Hello, ladies and gentlemen. This is Mr. Bryce with Susquehanna Valley High School here in Concord, New York, and there's my email address. We're on Unit 6 of the non-Regents version of Algebra 2 Common Core. This is Lesson 11, pages 41 to 44 of this great math teacher that made those lessons right there. If you don't understand me, you can scan that QR code and listen to him. We are going to be talking about locus. No, not that kind of locus. We're going to be talking about locuses of a parabola. The definition of a locus of parabola: the collection of all points equidistant. That means same distance from a fixed point known as its focus. Okay, a fixed line is known as its directrix. So there are two things. What in the world are you talking about, Mr. Bryce? I am talking about, with this picture right here, that's the focus and that's the directrix. Okay, they're labeled. So all of these points are exactly the same distance from that line. Let me see. It's 2 points and 2 points. Sorry, it's same two distance of 2 inches if we say each box is 1 inch. So it's 2 inches from the point and 2 inches from the line. There is a little bit more different to measure, a little bit more difficult to measure than that, but we're going to get to that in just a moment. So everything is the same distance from the focus and the directrix. Okay, so here we have the parabola y equals 1/4 x squared plus 1 is shown graph below with selected points shown for this parabola. Its focus point is 0, 2. Now, don't worry right now how we know that the focus is 0, 2 and that the directrix is the x-axis. Okay, we're going to figure that out later. Right now, we're going to say how far is the turning point 0, 1 from both the focus and the directrix. So because that is a vertical distance with a 90-degree angle from both of them, we can just count and say that 0, 1 is 1 unit from both. And what about the point 2, 2 and the point 2, 2? So let's take a look at it. 2, 2 is up 2, and it is also over 2. Is 2 units from both. Okay, so we can do that by examination. However, use the distance point to verify that 4, 5 is the same distance away from the focus and the directrix. Why can't I just count? So 0.45, oh, the shortest distance between 2 points is a straight line. That's a diagonal. Okay, so we're not going to be able to count it. We can obviously count that. That is a straight line, and we can count how many units it is. But this, we're going to have to use the distance formula. Remember, that I was just drawing with a smiley face a right triangle. So the Pythagorean theorem derives the distance formula. So let's fill in the points. Given the fact that the focus is the point 0, 2, I'm going to call this x2 and y2. And then the point in question, 4, 5, that's going to be x1 and y1. So I put them into the proper spot in the formula. And I get the square root of 16 plus 9, which is the square root of 25, which is 5. Now, let's see if we can actually count the distance. And it is 5. 1, 2, 3, 4, 5. The y-ordinate is the height away from it, and so we can have 5. So it does check that it is on the parabola. It wants us to draw a line. The test says draw a line so we can visualize it. Let's use a different color. Draw a line. Draw a line so we can visualize this. As I was drawing that line, I realized I have a smart board, so we can take a look at that. And here we go. We have that line between the 2 points. Is it really the same distance? Well, it appears to be the same distance. We proved algebraically that it is the same distance. Let me draw that line. Okay. Now it asks us repeat for the point 610. So we have the point 610. The distance is the square root 6 minus 0 squared plus 10 minus 2 squared equal square root of 36 plus 64, which is 10. And if we count, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 equals 10. It matches. Use the distance formula to show that the equation of this parabola is y equals 1/4 x squared plus 1, based on the locus definition of the parabola. Let me see. So we have the focus is 0, 2. So I wrote down the focus point and I wrote down the distance formula. Notice with the distance formula, I wrote y instead of x. Let's see if that works. I meant y instead of d. So let's take this nice and easy. The fact that, I have the distance formula. I can plug in the numbers. Y equals, let's see, yeah, just don't know what's going on here. Okay, yes, I do. But just keep on doing the algebra. Well, I know that x2 minus 0 is just, x2. And so if I square it, that's x squared. So y equals the square root of x squared. And now, I don't know how many of you can do this in your head. So let's do it down here. Y minus 2 squared equals y minus 2 times y minus 2. Well, that's y squared minus 2y minus 2y plus 4, which is y squared minus 4y plus 4. Hopefully by the end of the year we're going to be able to do those in our head. Definitely by pre-calculus. The end of pre-calculus we'll be able to do them in our head. So again, that was positive y squared minus 4y plus 4. I got to get rid of the square root. Oh, why don't I just square both sides? Y squared equals x squared plus y squared minus 4y plus 4. I squared both sides. Just still moving stuff around. Why don't I subtract the y squareds? Because remember, my destination doesn't have any y squareds in it. It just has y's. So I have 0 equals x squared minus 4y plus 4. Well, get the y over there. Add 4y to both sides. I have 4y equals x squared plus 4. Well, the only thing I have to do is divide by 4. And guess what? Y equals x squared divided by 4 is 1/4 x squared. And 1 divided by 4 is 1. We did it. Let's take a look at the next page now. Okay, you guys just came in for a class right now, so I'm going to divide this into 2 sections. So this is done in part A, and we'll do part B in just a minute.